Git is a free open source distributed version control system, which is designed to handle everything from small to very large projects with high speed and efficiency. Its functionality, performance, security, and flexibility are what teams and individual developers need, which also is one of the tools which make or break the DevOps process. Hi all, I welcome you to this session on Git, and through this Git tutorial, we are going to cover the following topics. We're going to start out by discussing what is version control, the concepts, its requirements, so on and so forth. Then we're going to talk about Git extensively. We're going to talk about its features, how does it work, followed by its installation and setup, both for Windows and for Linux systems. Then we are going to be moving on to Git Operations and Commands, where we shall be covering 5 aspects of Git operations, namely setting up repositories, saving changes, inspecting repositories, undoing changes, and rewriting history. Moving on, we are going to discuss SSH keys, what are SSH keys, and how to create SSH keys. And finally, we are going to summarize the whole session. Do kindly take up this time to subscribe to us, and don't forget to hit that bell icon to never miss an update from the Edureka YouTube channel. Also, to know more about Git, Jenkins, Docker, and other DevOps tools, do check out our training program, the link to which is given in the description box below. So without much ado, let's get started. So first of all, let's start out with what's version control. So to understand what is version control system, we need to understand first why we need a version control system. So we'll see why do we exactly need a version control system. So for that, let's take a scenario where there are 3 developers working remotely on a web application or a mobile application. Now, for simplicity's sake, let's just assume that it is a streaming application and one of them is working on a streaming page. Let's call them developer 1. Developer 2 is working on a user information page, and developer 3 is creating the payment portal. Now, all 3 of them are done with their respective pages at 10 o'clock, 11 o'clock, and 12 o'clock, respectively. Now, the thing is, all 3 developers are working in isolation. There may be their own changes, there may be changes in somebody else's page. They're all kind of adding some new files or modifying older files, changing the source code or something like that throughout the course of this project. But how exactly are they going to collaborate considering that they are working remotely? The solution to this is a version control system. With this system, I'll tell you what happens. At 10 o'clock, developer 1 uploads all the files regarding the streaming page. With a version control system, this modification is recorded and updated to one central directory or folder. So every time you're modifying an older file or adding a new file, it creates a snapshot of the latest version or the latest update of the changes that you've made or all the files that you've uploaded. So the snapshot of your update at 10 o'clock is saved, and then when developer 2 adds their user info page, this modification is also saved as a snapshot. Now there are 2 snapshots saved, and finally the payment portal page is added, and this is the last modification done at 12 o'clock, and this is the most recent snapshot saved, along with other snapshots of other updates and modifications done throughout the course of this project. Every change in your project, a snapshot is created and your entire project is saved that way. And these snapshots are actually known as different versions, which are basically the state of your project at a particular time or at the current time. It means that it will contain the kind of files your project is storing at one particular time and what kind of changes you have made so far between the previous version and this particular version. And this is exactly how a version control system works. So version control system basically is a system that records changes to a file or a set of files over time so that you can record specific versions later. These versions are recorded in a repository and they can be recalled anytime from these repositories during the course of your project. So version control systems essentially are of 3 types. Now, the local version control system is one of the simplest forms of VCS and has a database that keeps all the changes of the files under revision control. So all the files are saved by this one user and they manage all of the files. But it's actually really hard to maintain the changes of the file, and you can accidentally replace one or the other file that you need. It also needs something known as RCS, or revision control system, which keeps patch sets or the differences between updates in a special format on your disk. All of this, your local version control systems maintains all the track of all the files within your local system. As a user, you can track specific versions later, and it basically works as an independent standalone system for an application. So your applications like spreadsheets and word processors have this control mechanism. So that's one type. Apart from this, you also have your centralized version control system, which basically uses a central server to store all the files and enables team collaboration. So it's not one local system, but multiple systems which work on a single repository to which users can directly access as a central server. So the repository is a central server that could be local or remote, which is directly connected to each of the programmer's workstation. And the third kind of VCS is a distributed version control system. Now, these systems do not necessarily rely on a central server to store all the versions of a project file. In a distributed version control system, every contributor has a local copy or a clone of the main repository. So everyone maintains their own local repository, which contains all the files and the metadata present in the main repository, and they can push or commit or update the main repository if and when required. Now, we are going to cover more on the latter two version control systems further in the session. So now let's try and understand in depth what's the difference between a centralized version control system and a distributed version control system. As I had mentioned before, in a centralized version control system, each programmer working on a branch, on a project, has absolute access to the central server. So the centralized version control system uses a central server to store all the files, and everybody on the team can directly access the central server as it is one single repository. So if you have 3 workstations, workstation 1, workstation 2, workstation 3, all of them can directly commit to the repository and get updates from the repository, which is your central server. The repository here indicates a server that could be local or remote, directly connected to each programmer's workstation. Every programmer can extract or update their workstations with the data present in the repository, or can make changes or updates or commit in the repository. And every operation is performed directly on this repository. Even though this seems pretty convenient when we are just talking about 3 people, to maintain a single repository like this has some major drawbacks. One of them is that it's not locally available, meaning every change that you have to make, you will have to be connected to a network to perform any action. Also, in any case, the central server getting crashed or corrupted will result in losing the entire data of the project. Also, another small thing which is revertible, but is if one person accidentally makes some unwanted updates, instead of his or her local system, they will be making that changes directly in the central server. So recovering that part back will be again a time consuming process. This is where distributed version control systems come to the rescue. Now, these systems do not necessarily rely on a central server to store all the versions of a project file. In the distributed version control system, each and every contributor has a local copy or a local workstation clone of the main repository. That is, everybody maintains a local repository of their own which contains all the files and metadata present in the main repository. You will understand it better if you take a look at the diagram. As you can see, every programmer maintains a local repository or a local copy on its own, which is actually the copy or clone of the central repository on their local hard drive. They can commit and update their local repository without any interference from one another. And then they can update their local repositories with new data from the central server by an operation called pull. Once they are done with their bit of the code, they can affect the changes of the main repository by an operation called push from their local repository. Now, this system or this act of cloning an entire repository to your workstation and making all the changes on a local repository gives you a couple of advantages over a centralized version control system. First of all the operations except push and pull are very fast because the tool only needs access to the hard drive and not a remote server. Hence, you do not always need to be connected via a network connection, or you always do not need an internet connection. Committing new change sets can be done locally without manipulating the data on the main repository. Once you have a group of change sets ready, you can push them all at once. So you complete your set of code on your local system and then you push all the files once and for all into the main repository. Third, since every contributor has a full copy of the project repository, they can share changes with one another on wanting to get some feedback before affecting the changes in the main repository. So this enhances the essence of collaboration amongst a development team. And finally, if the server gets crashed at any point in time, the lost data can be easily recovered from one of the contributors' local repository. And that is why distributed version control system has been picking up popularity over the past decade. So why version control is important? First of all, it helps collaboration. It allows remote development, shared workspace, and real-time updates. All versions of your code are preserved, hence it helps you manage versions of the same code. Easy rollback from current version. Suppose a part of your project has been headed to a wrong direction, you can easily roll back from the current version to the last version which was stable. Now, because you can reverse faulty updates, you can save time and hence it reduces downtime of your project development. And finally, it improves visibility. You can analyze and compare different versions, and that gives you like a 50-foot top view of your entire project, which just accelerates your product delivery. So now that you have a bare sense of what is version control and why do you need version control, let's understand one of the most popular version control systems that exists today, and that is Git. So Git is a distributed version control tool that supports distributed nonlinear workflows by providing data assurance from developing quality software. So basically what it does is that it lets you and your team of developers work together on the same project remotely from anywhere across the world. Your team members can work efficiently on files and easily merge their changes into one source without the fear of losing or deleting anything of importance due to the easy rollback feature. Git is primarily used to manage your project comprising of a set of code or text files that you may want to change from time to time. Now, Git is an integral part of DevOps. DevOps, as most of you might have the idea of, is the practice of bringing agility to the process of development and operations. A couple of years ago, it was this entirely revolutionary ideology which swept IT organizations worldwide, boosting project life cycles and in turn increasing profits. DevOps promoted communication between development engineers and operations participating together in the entire life cycle, from design through development process to production support. Now, in the entire life cycle of DevOps, starting from planning of the projects to its deployment and monitoring, Git plays a vital role. When it comes to managing the code that collaborators contribute to the shared repository, this code is extracted for performing continuous integration to create a build and test it on the test server and eventually deploy it to production. Tools like Git enable communication between the development and operations team. When you are developing a large project with a huge number of collaborators, it is extremely important to have communication between the collaborators, between the developers while making changes in the project. Commit messages in Git play a very important role in this particular collaboration or communication amongst the team. the bits and pieces that we deploy or update, lies in this version control system, such as Git. To succeed in DevOps, you need to have all the communication in version control. Hence, Git plays an extremely vital role in succeeding at DevOps. And due to this very reason, Git has earned way more popularity compared to other version control tools available in the market, such as Apache Subversion, concurrent version systems, and Mercurial. If you compare the interest of Git by time with other version control systems, you shall realize that larger companies' products are generally developed by developers using Git all around the globe. And some famous names out of them are Facebook, Yahoo, Zynga, Quora, Twitter, eBay, Salesforce, Microsoft, and many, many more. Now, lately, all of Microsoft's new development work has been in Git features. Microsoft migrating .NET and many of its open source projects on GitHub, which are managed by Git. One of such projects is the LightGBM. It's a fast, distributed, high-performance gradient boosting framework based on the decision tree algorithms, which is used for ranking, classification, and many other machine learning tasks. Here, Git plays an important role in managing this distributed version of LightGBM by providing speed and accuracy. So basically, to enable version control, Git is your go-to solution. It's fast and suitable for handling massive code bases scattered across multiple developers, which makes it the most popular tool used today. Now that you know about Git, a terminology we'll be using a lot while talking about Git and GitHub is a repository. Now, repository, or a repo as it's most commonly known as, is a directory or a storage space where your projects can basically live. It can be local to a folder or your computer, or it can be a storage space in another online host such as your GitHub. And in this particular space, in this particular directory, you can keep your code files, text files, images, you name it, all of it inside a repository. Through the course of this, we shall also be talking about something known as GitHub, which is nothing but a central repository, the kind that we spoke about when we discussed centralized versus distributed version control systems. There's a central repository, and that is where all of your code will live. You have your local repository where you'll make the changes, and there you have the central repository to which you will push all of the changes. Yeah? And the central repository is something that all of the developers involved in this particular project, in a certain project, have access to. All right, moving on, let's discuss a few Git features which make it so popular amongst organizations as well as individuals. First of all, it's economical. It's free and open source. Git is released under GPL's General Public Licenses, open source license, so you don't need to purchase Git. It is absolutely free, and since it's open source, you can modify the source code as per your requirement. Second is its speed. Now, since you do not have to connect to any network for performing all of the operations, it completes all the tasks really fast. Performance tests done by Mozilla showed it was an order of magnitude faster than other version control systems. Fetching version history from locally stored repository can be 100 times faster than fetching it from the remote server. So the core part of Git is written in C, which avoids runtime overheads associated with other high-level languages, which makes it extremely fast compared to other version control systems. Next is that Git supports non-linear development. Git supports rapid branching and merging and includes specific tools for visualization and navigation of a non-linear development history. A core assumption in Git is that a change will be merged more often than it's written, as it is passed around various reviewers. Hence, branches in Git are very, very lightweight and is only a reference to a single commit. With its parental commits, the full branch structure can be constructed. Next, let's talk about the robustness. Nearly every single task in Git is undoable. Git gives each developer a local copy of the entire development history and the changes copied from one repository to another. These changes are imported as additional development branches and can be merged and deleted and recovered the same way as a locally developed branch. Next is the snapshots, which are recorded changes made to a file rather than the file itself. Followed by which you have integrity, which means no changes can be made without Git recording it. Since every contributor has their own local repository, on the events of a system crash, the lost data can be recovered from any of the local repositories. You will always have a backup of all of your files, and none of the changes made to the central repository will go unlogged by Git. Git uses the SHA-1 or the secure hash function to name and identify objects within its repository, and every file, every commit is checksummed and retrieved by its checksum at the time of the checkout. The Git history is stored in such a way that the ID of a particular version, a commit in Git's terms, depends upon the complete development history leading up to that commit. Once it's published, it's not possible to change the old versions without it being recorded. Then it's a distributed system, which means every user has their own copy of the repository and the data is stored locally. Git gives each developer a local copy of the entire development history, and the changes are copied from one such repository to another. These changes are imported as additional development branches and can be merged in the same way as a locally developed branch. And finally, it's easy branching. Now, branch management with Git is very simple. It only takes a few seconds to create, delete, and merge branches. Feature branches provide an isolated environment for each change to your code base. So when a developer wants to start working on something, no matter how big or small, they can create a fresh new branch which is not interfering with the main branch, which ensures that the master branch or the main branch always contains production quality code. So any little experimentation that you want to do or little things that you want to try out can always be on a separate feature branch instead of the changes made to your master branch. Because ultimately, your master branch should contain your publishable product. So now that you know the basic features of Git, let's try and understand what the basic workflow of Git is, or how does Git work. So the basic overview of how Git works goes like this. You basically create a repository or a project with a Git hosting tool like Git or Bitbucket. You copy or clone the repository to your own local machine or your working directory. You add a file to your local repository and commit the changes, which basically means you save the changes. Then you push the changes to your master branch. Then you make changes to your file and commit. Then you pull the changes to your local machine. You create a branch or a version, make a change, commit the change, same process, open a pull request, and merge your branch to the master branch. Now, this is a little complicated listening to it like this, but once we get on to our demonstration, I think things will be way more clear. You can still take a good look at this diagram, but if you don't get it, don't worry. I will be explaining these operations one by one when we get to the demonstration part of this Git tutorial. Moving on, let's get to the good part, the hands-on section, starting with the installation and setup of Git. Now, there are two ways in which this goes. First of all, for Windows users, you need to install Git Bash for Windows. And for Linux users, you'll have to start by updating the package index and then install Git using the terminal. So first of all, for our learners using Windows, you'll have to log on to gitscm.com/downloads and then click on Downloads for Windows button and then run the executable file and follow through till you finally install Git Bash. I'm not going to install it completely as I already have Git Bash downloaded, but I'm still going to open the page to show you guys. All right. So the latest source release is Git 2.30.1 on the 8th of Feb, and you can just click on this button. The moment you click on this button, it's going to start downloading Git for you. And once you have the executable file, all you have to do is open it or run it in your own system, right? Next, for people using Linux, this is an example considering you are using Ubuntu. If you're using CentOS, a lot of the commands don't change, but instead of apt install, you will be using yum install for CentOS. So for that, now I'm going to open my terminal on a virtual machine. So here I have running an Ubuntu machine using the Oracle VirtualBox. So I'm going to start by running an update. All right, this is going to take a while. Kindly be patient. So here I have my Ubuntu running on a virtual machine. So to install Git on your Ubuntu machine, you have to start by updating. So this will take some time. We're going to use sudo apt update. If you're using CentOS, you will be using yum instead of apt. Let's clear that out, and then we're going to install Git. And then you can look for the Git version. Yeah? All right. Now that we have our Git installed, let's go ahead and look at the operations and commands that we are going to take a look at today. You have your repository setup, which include the commands init, clone, config, and alias. Then you have your save changes operations, which have your add, commit, diff, and stash. All of these commands we are going to go on and off and look at collectively mostly. Then we are going to look at the inspect operations, your inspect repository operations, of which the git status command is something we are also going to look at throughout this demonstration right from the beginning. So apart from that, you have your git log, git tag, and git blame commands. So you have your merge rebase command. So let's move on to our first set of Git operations. First of all, you have your git init command, which basically creates a new empty Git repository. Now, this can be used to convert an existing unversioned project to a Git repository or initiate an absolute fresh Git repository. Now, most other Git commands are not available outside of the initialized repository. So this is usually the first command that you will run in a new project. That is, if you're using git bash. So when I run git init, it reinitializes an existing Git repository, which I already have here. Now what this does is it reinitialized my existing Git repository in this particular directory, in this .git directory. Yeah. What git init does is that it creates an empty Git repository or reinitializes an existing one, like it did for me right now. It basically creates a .git directory with subdirectories and template files. And when you run the git init command in an existing repository, it will not overwrite the things that are already there. It'll rather pick up the newly added templates. So that's the repository initialized. You can go ahead and create some files in the directory or repository, whatever you call it. Now that is about initialization. Now, what about if there was an existing repository on Git that you had to act upon, that you had to make updates to, that you had to add files to, things like that? That's where you use the git clone utility. Yeah. Now you have the git clone utility, which you use to target an existing repository and create a clone or copy of this particular repository on your local machine. Now this is one of the features provided to you by a distributed version control system, as we had discussed before. So this is a blank file called Edureka rep with just the readme text file. Let me just go ahead and copy this, and then I can just git clone and paste its HTTPS URL. And as you can see, it's cloning this into Edureka rep. And now if I change directory to Edureka rep, you can see the readme file is right there. Yeah. So we're basically going to work off of this particular repository today. Edureka rep. Yeah. So now that we created a clone, moving on, we have the git config command, which basically is a convenience function that is used to set up your git configuration values on your global or local project level. This command is basically used to modify your configuration text file. So if I typed git config global user.email, and here I type, so there I gave in my email ID as the global user email ID. So if I ask for what the global user email ID is, it will return my ID back to me. Yeah. Basically, these configuration levels, like your username and your user ID, correspond to your .git config text files. Now, executing this basically will help you modify the configuration text file. Git uses this series of configuration files to determine non-default behavior that you may want. Yeah. So the first place Git looks for these values is in the system-wide configuration file, which contains settings that are applied to every user on this system. So basically, if you pass the option to your git config, it will read and write from this file specifically. And the next place the Git looks is the config/git config file, which is specific to each user. Now you can make Git read or write to this file by passing your global option, which is what I did. And the final command in the setup operations that we are going to look at is an alias. Now, alias, as the name suggests, is basically used to create shorter commands that map to longer commands. They enable more efficient workflows when you obviously have to use lesser keystrokes to execute a command. There are these lengthy commands which obviously kill a lot of your time. So these aliases you can use to shorten those commands. And these are also something that you will create via the git config command. There isn't really a direct way or a direct command of creating aliases. Yeah, this is just something I wanted to add in here along with the git config command. Like a very common alias created is CO for checkout or anything else, CK for checkout. So yeah, this is something that you can do using the git config command, just creating aliases. Moving on, let's look at operations that you use to add changes and save changes to your Git repository. Now, the first two commands here that we're going to look at are git add and git commit. Now, this combination is basically used to create these snapshots that I was talking about initially in the session, right? So basically what you do is first you use the git add command to add a change in your current directory or your working directory, and you add that to the staging area. It tells Git that you want to include a particular set of updates or changes in a particular file in the next commit. Then what you do is you move on to git commit after making the changes to your working tree. Then you use the git commit command, which captures a snapshot of your project's current state. So basically, you use add to update the index using the current content found in your working tree, and then you basically prepare the content in the staging area for the next commit. Then you run the commit command to take that snapshot of your project's current status. Now remember, this is very important and you have to do it each time. You must use the add command to add any new modified files to the index. You can't directly commit anything without adding it to the stage area first. Now what I did was I quickly went ahead and added 3 files to my repository Edureka rep. So if I go into this repository, you can see there are 3 files: Edureka file 1, file 2, file 3. Now let's see if these files are in my index or not using the command git status. Now git status basically displays the state of the working directory and the staging area. It will list all the modified files which are ready to be added to the local repository. It lets you see which changes have been staged and which haven't, which files are being tracked by Git and not. So if I typed git status, you can see on your main branch, you have 3 untracked files, which are the 3 files that I just added, Edureka file 1, 2, and 3. These are not added to the index yet. This means I cannot commit these changes unless I added them explicitly to the index. So now we are going to add these 3 files. This command will update the index using the current content, which is found in your working tree, as you can see in front of you, and then it'll prepare the content in the staging area for the next commit. So either I can just git add and put in the directory name, or I can just use git add with an extension of a, which means all, and this will add all of these files to the index which are in the directory but not updated in the index yet. Yeah, now I've done that. Let me go ahead and use git status again, and you can see all of these file names are written in green, and you can see changes to be committed written here, which means all of these changes are ready to be committed. They are added to the index. Now these files are added to the index. You're ready to commit them. Now, as I had mentioned before, we're going to commit them, and committing refers to recording the snapshots of the repository at any given time. So your committed snapshots will never change unless it's done explicitly. So I'm going to clear this, and we're going to commit this by typing git commit and then adding a tag or a message called committing 3 files. Let's try this out. As you can see, 3 files changed, 3 insertions. You can see our Edureka files 1, 2, 3 have been committed. The git commit command has committed the changes in the 3 files in your local repository. Now, if you want to commit a snapshot of all of the changes in your working directory at once, you can always go with commit-a. Now, let me add a couple more files to my directory just to show you the difference between your files added to the index versus the ones that are not. If I type ls again, you can see there are 2 more files over here. As you can see, I have 2 other files. I'm just going to add the Edureka file 4 and not the file 5. And then I'm just going to git commit committing files. And as you can see, only 1 file changed, only 1 insertion happened, and that only happened because Edureka file 5 is not added to the index. And even if I use the extension A, I cannot add Edureka file 5 because that has not been added to your index. Now if I just go ahead and add Edureka file 5, voila, the change has occurred in our Git repository. Now if I typed git status, there are no more files to add or commit. Our branch is ahead of the origin or main branch by 3 commits. And you can use git push to publish your local commits. Now what is git push? This is something we will cover later in this session. Now understand that before you affect the changes made to the central repository, you should always pull changes from the central repository to your local repository just to get the most updated version of your branch. You'll get all the work of your collaborators that have been contributing in the central repository. For that, you use the pull command. Now, as you can see, there's nothing to commit and your working tree is clean. There are other commands like the git status command, which you could use for similar purposes. For example, you have the git log command, which only operates on committed history. It basically will display to you the committed snapshots and will let you list the project history, filter it, and search for specific changes. So if you typed git log, it's going to show you all the commits that have happened since we started with this git file. Okay, so you can see at the bottom, your original main, there's your initial commit, right? Then our first commit where we committed 3 files, then we committed the 4th file, and finally when we committed file number 5, right? These are all the commits, including the initial commit, the first one. Yeah, along with the author and the date and time. Remember when I told you about everything is recorded when you're using Git? This is what I meant. Can always access who made commits at what time and what commits were made when you use a version control system such as Git. Now, at a point like this, I think it's crucial to mention one more command, which is the git tag, and it's used to basically capture a tag in history or a point in history that is used for a marked version release, right? So it's basically like a branch that doesn't change, and after being created, they have no further history of commits. Yeah, so that is one. And another one is git blame. Now, the git blame function displays of the author's metadata attached to a specific committed line in a file. It's used to examine specific points in a file's history and get context as to who the last author was that modified that line. So if I went back and typed git blame Edureka file 5.txt, it's going to show who the person is that is to blame, who committed this particular file or made this particular change, right? It'll also, if you paid attention, give you the commit number. As you can see, this E9D63EFO commit number. This also has this E9D63EFO, which is the first few characters of this particular commit number. Yeah. So now that you know how to check the status of the changes and see who made the changes, it's time that you understand how you fetch changes from your remote repository to a local repository, and how you push commits from your local repository to your remote repository. So here we are going to look at two commands called pull and push. Now, first of all, you have the git pull command, which fetches changes from your remote repository to a local repository. Basically, it merges upstream changes in your local repository, which is a common task in Git-based collaborations. But at first, you need to set your central repository as the origin using the command git remote add origin, and I'm going to add the link to my central repository, which is this. And as it says, the remote origin already exists. Now that your origin is set, and now we're going to pull our main branch. So I'm just going to type git pull origin main, and it says we are already up to date. Now, certain number of tutorials or documents that you might be following might even give you the command git pull origin master, in which case you're working on the master branch. Now, to know which branch you're at, you can just use the command git branch vv. Yeah, I'll tell you which branch are you working on. Yeah. So yeah, we are working on the main branch, and we are already up to date with the branch, since my local repository was already updated with files from the main branch. This is the message of an up-to-date branch. Now you can also use git pull origin and your whatever branch name. Here I'm using main. That's a mistake on my part. Maybe I was trying to clear the screen. All right. So here, even if I pull from the branch using git pull origin and the branch name to my local Git repository, you can see it's already up to date. So now my local Git repository is now all updated with the recent changes. So now it's time to make the changes to your central repository by using the push command. So we're going to use the push command. This command transfers commits from your local repository to your remote repository, and it is basically the opposite of your pull operations. Pulling will import commits to your local repositories, whereas pushing will export commits to your remote repositories. It's going to ask you for your username. and password before it lets you push into your main branch there. So I've put in the username and password for my GitHub account, and with that, this has pushed the changes from my local repository to the remote repository along with all the necessary commits and internal objects. Now this has created a local branch in your destination repository. The use of Git push is to publish your local changes to a central repository. After you've accumulated several local commits and are ready to share them with the rest of the team, you can then push them to your central repository by using the git push command. Now, the files which have already been committed previously in the commit section and they were all push ready, you will use git push origin master to reflect these files in the master branch of your repository. All right. So let's go ahead to our repository and see if changes have been made. And yes, you can see all of our files on our GitHub repository. You have Edureka file 1, 2, 3, 4, and 5. All the 5 files that we had created on our local repository. Yeah, you have all these 5 files and the README file here. Here also you have the README file and all the 5 files that we had created. Now at this point in this Git tutorial, I hope you have understood the basic commands of Git. You have pulling, pushing, adding, committing, things like that. Now let's take a step further and understand the 3 basic commands of parallel development. Here I'm going to be talking about branching, merging, and rebasing. So first of all, let's talk about merging. Now, merging is a way to combine the work of different branches together. This will basically allow you to branch off, develop a new feature, and then combine it back in. As you can see in the diagram, it shows you 2 basically different branches, new branch and master. Now, when we merge the work of the new branch into the master, it creates a new commit, which contains all the work of the master and new branch. Now, if we merge the 2 branches with the merge command, as I had mentioned before, Git allows you for easy branching, which means you have parallel branches with your master branch that help you carry on your individual work while not interrupting your main product, which is your master branch or your main branch. So branches in Git are nothing but pointers to specific commits. Yeah. So Git generally prefers to keep its branches as lightweight as possible. Now there are basically 2 kinds of branches via local and remote tracking branches. A local branch is just another path of your working tree. On the other hand, the remote tracking branches have special purposes. Some of them are linking your work from your local repository to your central repository and automatically detecting which remote branches to get changes from when you do a git pull. So you can check what your local branch is by using git branch. So you know you are at your main branch. And the one thing you should understand, one thing is like a main mantra of people who use Git are branch early and branch often. Yes. So to create a new branch, you're going to use a command git branch and your branch name. And in this case, I'm just going to use a branch name Edureka images. All right. And here you can see this diagram shows the workflow of a new branch that is created when we create a new branch. It originates from the master branch itself. So since there's no storage or memory overhead with making many branches, it's usually easier to logically divide your work up than having big chunky branches. Hence, the branch often part. Now let's see how to commit using branches. Now branching includes the work of a particular commit along with all parent commits, right? So as you see, the new branch has detached itself from the master or the main branch, and hence it'll create a different path. So we are going to git check out the branch name, which in our case is Edureka images. And then we are going to git commit. So you have untracked files, Edureka images, and nothing added. So you made that branch. Now, merging is a way to combine the work of different branches together. So basically what this does is, now that we've branched off to something known as Edureka images, you can go ahead, add files to it, develop a new feature, and then combine it back into your main branch. Here you can see two different branches. You have your new branch and your main branch. And when we merge the work of a new branch into the main branch, it creates a new commit, which contains all the work of the main branch and the new branch. So now if we merge this branch, as you can see, it's already up to date. It's important to know that the branch name here should be the branch that you want to merge into the branch that you're currently checking out. So make sure that you are checked out of this destination branch. So let's just merge all the work of the branch Edureka images into your main branch. For that, I will first check out my main branch and then merge Edureka images with git merge Edureka images. And as you can see, all the data from the branch Edureka images has merged into the main branch. Now notice that merging in Git creates a special commit that has two unique parents. Now this is one way of merging into the main branch. There's also another way of combining the work between two branches, which is called rebasing. Now rebasing takes a set of commits, copies them, and stores them outside your repository. The advantage of rebasing is that it can also be used to make linear sequence commits. The commit log or the history of the repository stays clean if rebasing is done. Now our work from the new branch is placed right after master, and we have this nice linear sequence of commits. This command doesn't copy but moves all our work from the current branch to the master or the main branch. They look like they've been developed sequentially instead of having developed parallelly. So if I just did another branch called git branch Edureka images 2, and then maybe git checkout, okay, then we git commit this, and then I could just git rebase main, and your current branch will be up to date. This command basically moves all of your work from your current branch to your master branch, and it'll basically look like it has been developed sequentially instead of having developed parallelly. Now, apart from these, there are certain operations that you ought to know. Firstly, archiving your repository. You can use this command. It stores all of your files and data in a zip file rather than a .git directory. This creates only a single snapshot, omitting version control completely though. This comes in handy when you want to send these files to a client for review who doesn't have Git installed in their computers. Apart from this, you can also bundle your repository, which basically turns your entire repository into a single file. This pushes the master branch or the main branch to a remote branch, only contained in a file instead of a repository. You could alternately change the repository, clone the repo bundle, create a copy, and use git log, but that is like 5 commands instead of one. Why not just use one command? And finally, stashing uncommitted changes. When you want to undo adding a feature or any kind of added data temporarily, we can always stash them temporarily. You can use git status, stash status, and then you want to reapply the changes you stashed using git stash apply. Having said that, let's move on to another very important topic in this Git tutorial. Let's go through a brief introduction to SSH. Now, what is SSH? What is an SSH key? Now, an SSH key is an access credential for Secure Shell Network Protocol. It's basically an authenticated and encrypted secure network protocol and is used for remote communications between machines on an unsecured open network, for remote file transfer, network management, and remote operating system access. So basically, it's typically used to log into a remote machine and execute commands in it. But this also supports tunneling, forwarding TCP ports, and X11 conditions. It can transfer files using associated SSH file transfer or secure copy protocols. It provides you several alternative options for strong authentication and protects the communication security and integrity with very strong encryption. It's a secure alternative to the non-protected login protocols and insecure file transfer methods such as FTP. So basically, how do you create SSH keys? You start by using the command ssh-keygen, and then you'll be prompted to enter a file in which to save the key. So home, Edureka. Then we're going to enter a passphrase. I'm just going to leave it empty again. And you can see our identification has been saved in the file that we specified. And we have something known as a key fingerprint. And finally, what we have to do is add the new SSH key to the SSH agent. And then you will see identity added. And that's it. You have created an SSH key. Now I hope through this session you have enjoyed learning about Git and its operations and commands. Let us know in the comment section below if you would like more sessions like these. Git is an extremely capable distributed version control system where every developer has the agency to work on a development as a whole. This is a beautiful gift to everybody on a development team, conceptualized by Linus Torvalds, and will prove to be beneficial to all individuals, institutions, and organizations to implement in their development journey. With that, I would like to close the session. My name is Upasna. Thank you and have a great day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!